Good morning, everyone. Today we are going to continue working on the review for test 4. We covered the first 6 questions, and today we start with question number 7. The half-life of a certain substance is 28 years. How long will it take a 52 milligram sample to decay to a mass of 13 milligram? Very simple problem, right? This is about an exponential decay. This is an exponential decay problem. The formula P equals P sub 0 times e to the power RT. That's the formula for exponential growth or exponential decay problem. P here is the mass of the sample. how many milligrams. P sub 0, this is not multiplication, this is P sub 0. P sub 0 is the initial mass of the sample. E is the Euler number, is a constant, irrational, around or equal to 2.7. R is the rate, T is the time. We are looking for the time, okay? We are looking for the time such that the substance can decay to a mass of 13, right? After T years, the mass becomes 13 when initially the mass is 52. P sub 0 is the initial mass, right? 52 times e to the power RT. So in order to find the value for T, we have to know the value for R because we only have a one equation. This is a one equation. T is the unknown we are trying to figure out, but we have to know the value of R in order to do that. How do we find the value of R? We have the first sentence gives us a piece of information. It says the half-life of the substance is 28 years. How do we take advantage of that piece of information? Formula again, P equals P sub 0, e to the power RT. Half-life is 28 years. That means after 28 years, when T equals 28, the mass of the sample become half of the initial mass, right? After 28 years, when T equals 28, the P equals half of the initial mass, half times P sub 0. In this equation, since both sides have a factor P sub 0, if we divide each side by P sub 0, we can cancel the P sub 0, right? Then we would have half on the left side. On the right side, we have e to the power of 28r. R times 28 is the same as 28 times r. After that, we can apply natural log function on each side to get rid of the base of the exponent. On the left side, we have ln half. On the right side, remember the power rule? You should, at this point, you should be very familiar with the power rule now. Formula for power rule. Log with base b, x to the power r. R is the exponent in the argument. We can move the r in front, and then times log with base b, x, right? So we can move 28r in front of the ln. We would have 28r times ln e. We all know ln e is 1, right? So we can get rid of that factor. And we have ln half equals 28r. One more step to find the value of r. Divide each side by 28. We have r isolated on the right side. Then we have the left side equals ln of half over 28. That's the value of r. We got the value of r by using the half-life of the substance. Once we have the value of r, we can solve this equation for T. Let's see. Similarly, we're going to divide each side by 52. Cancel. Then on the right side, we have the exponential function e to the power RT. Left side, we have 13 over 52. 13 over 52 is a quarter, I believe. 13 times 4, yeah. 13 over 52 is a quarter. 13 times 4 is 52, so 1 over 4 equals e to the power RT. And then we use the same method. Take ln on both sides. And on the left side, we have ln 1 quarter, a quarter. On the right side, use the power rule again to move the exponent in the argument in front of the log. So we have r times t multiplied by ln e. Again, ln e is 1, right? So that factor gonna go away. Then we have ln a quarter equals r times t. ln e is 1. And then we divide each side by r, knowing r is known now. It wasn't the beginning, but we figured out this is the value of r. So r is known right now. So divide each side by r, we cancel r. We have t isolated on the right side, and the left side is ln a quarter over r. Okay, so let's see if we can simplify the expression that represent t. T now is ln a quarter on the top, r in the bottom. R is the pink, right? Let's bring the pink in the denominator. Ln half over 28. You can try to keep changing flip, right? Numerator divided by the denominator, the pink, which is r. And we can try keep changing flip. Keep the first fraction, change the division to multiplication, and flip the second fraction. Now 28 gonna go on the top, ln half gonna go on the bottom. And then we multiply across, numerator gives 28 ln a quarter, denominator gives ln half. This is good enough to enter in a calculator, but if you wanna play with it, I can just play with it. Of course, it's not very necessary. It's optional. I can play with the log, write ln 1/4 as ln 4 to the power -1, and then write ln half as ln 2 to the power -1, right? A quarter is 1 over 4, which is 4 to the power -1. 1 over 2 is 2 to the power -1. And we can move the -1 in front, move this -1 in front, and we have -1 times 28. Oh, I need more space. Start a new line. Yeah, the blue part just optional, just want to play with it. And then we have negative 28 ln 4 on the bottom, negative ln 2, and negative cancel negative, right? Numerator is negative, bottom is negative, so they cancel. And we end up with have 28 on the top, ln 4 over ln 2. Yeah, why would this help? We just make it a little bit simpler. So really, this is good enough just to enter in a calculator, or you can just enter this one as well, right? If you see it. Okay, let's see what do we have if we enter this expression in the calculator. Okay, I would have to start the app of the TID for a calculator emulator, and then switch the share. Okay, so let me stop share and then go share the calculator, right? Yeah, you are sharing the calculator. Okay, I remember it's 28 on the top, right? I like to play with the structure, so I use a parentheses. Well, you don't have to. If you have a quotient, you can do the numerator first, which is 28 times ln 4. Let me double check the. Yeah, 28 times ln 4. That's the numerator, right? Once you have the numerator divided by denominator, denominator is ln 2. Close the argument. 56. Let's go back. Stop sharing the calculator. Let's go back the note. 56 is the answer, right? It takes 56 years to decay to 13. Actually, we have another method for this problem. Yeah, we do have another method for this problem, okay? 28 is a half-life. And method number 2, the number is pretty convenient. So originally the mass is 52, right? After 28 years, the mass will reduce to half of 52, which is 26, right? And another 28 years, it'll reduce to half of the 26, which is 13. So 28 years plus 28 years, 56 years. This is a lot easier, right? Okay. So if the number not convenient, we do need to go through the process But if the number is very convenient, like this example, specific example, we can just use the meaning of the half-life to get it done. Yeah. So it's good to always look at the numbers, right? 52 become half of it is 26. That takes 28 years. And from 26 to 13, another 28 years. So 56 years. Okay, you use this method, okay? Use this method. Use this method. Next, 28. Next, question number 8. The doubling period of a bacterial population is 20 minutes. At the time t equals 120 minutes, the bacterial population was 70,000. What was the initial population at time t equals 0? Okay, we're going to use doubling period, doubling time, double time, 20 minutes. Okay, the unit is in minute. 20 minutes. If we go from the initial, which is x, right? Initially, when t equals 0, when t equals 0, the mass is x. And after 20 minutes, double to x. When the time is 40, yeah, compare with the initial. After another 20 minutes is double to x, which is 4x. And another 20 minutes, which is 60, right? Another 20 minutes, you double 4x, which is 8x. Another 20 minutes, which is 80. You have you double another 20 minutes double, right? Double 8x, you have 16x. Another 20 minutes, so that's 100 minutes from the initial time. We double the 16x, which is 32x, and another 20 minutes, 120, and then the mass of the sample would be double of the 32x, which is 64x, and the 64x, after 120 minutes, the bacterial population was 70,000. That is 70,000. 2, 3, 4, right? And then we have an equation now. 64x equals 70,000 divided each side by 64. Cancel x equals 70,000 over 64. What was the initial population at the time t equals 0? It doesn't say the rounding. I think might be we don't need to round it. I think we don't need to round it because 64 just has factor 2. Let me get a scientific calculator. You might not see it because it's a different app, but you can calculate this quotient easily, right? 70,000, 1, 2, 3, 4, divided by 64. It gives 1,093.75. That's the initial population. 175. The doubling period of a bacterial population at time, okay. So 6, double 6 times. Once, twice, 3, 4, 5, 6 times. And yeah, that's the initial population. Second part, find the size of the bacterial population after 3 hours. 3 hours is 180 minutes, right? We can keep going. For another 20 minutes or 140 minutes, the population doubled. So twice of 64x, which is 128x. After another 20 minutes, which is 160 minutes from the beginning, we doubled 128x, that is 256x. And after another 20 minutes is 120 minutes, right? Yeah. and we double the 256x, and that gives us 512. Double check. 256 and 2, 12, 1. Yeah, I think so. Yeah, correct. Let me erase this. So from the very beginning, the initial time is t equals 0. After 3 hours is 180 minutes, and the population is 512 times x. Okay, and your answer is not 512. It's 512 times x. And what is x? X is this value we just got. So the second part, the answer is going to be 512 times 1093.75. Let's see what that equals to. Times 512. 560,000. 560,000. Okay? Oh, we shouldn't do K, it's not money. 0, 0, 0. 560,000. All right? So this problem, we did not use the formulas. All we did is to use the doubling period of the bacterial population that is given. It's a little bit long, as you can see, every time 20 minutes, right? But it's not too bad. I think this probably is easier than using the formula. All right? Let's continue. Question number 9. The pH scale for acidity is defined by pH equals negative common log. 10 here is the base. The bracket here, inside the bracket, we have the H plus, where the bracket H plus is the concentration of hydrogen ions measured in moles per liter. A solution has a pH of 12.65. Calculate the concentration of hydrogen ions in moles per liter. Write the answer in explicit scientific notation with at least 2 decimal places. Okay. Well, this part looks very complicated, it looks very fancy. Just see that as one whole thing. That is the argument of the formula, okay? That's the argument of the formula. In this problem, the formula is given, then we're going to use the given formula. pH value equals negative log with base 10, right? Yeah, we can do 10 here as well. And, the star. The star is the hydrogen ions in moles per liter. So the concentration, as it says, this part, the green part, is the concentration of hydrogen ions measured in moles per liter. We are looking for the green part. We are looking for the green part. Okay, we are looking for the star. Yeah, we are looking for the star. You can use X if you like. We can use X. Yeah, we can use X. And that's the green part. All right. So calculate the concentration. Write the answer. Okay, the concentration is, enter scientific notation. Okay. All right. So let's see, do we have pH given? Yeah, a solution has a pH of 12.65. So on the left side, the value of pH is given 12.65. Plugging in and equals negative log with base 10 and the green, right? Which is the concentration and so on. This equation is a simple log equation. Well, what about the negative sign? That's easy. We just divide each side by -1, right? To get rid of it. Then the right side is just the log with base 10 of the argument. On the left side, we have a negative 12.65. Right? Do you guys remember the conversion of the two forms of the equation? Log with base B star triangle, right? B is the base, star is the argument, triangle is the log. How do we convert to its equivalent exponential form? base is carry the log on the shoulder equals argument, right? We're going to do the same thing. In this case, the base obviously equals 10. The argument is green, concentration, and so on, very long. And the log is negative 12.64. All right, let's convert now. The base is 10, carry the log on the shoulder, negative 12.65 equals argument. Argument is x, right? And that's the x we're trying to figure out. We want to know what's the x. So here, that's the x. And x equals 10 to the power negative 12.65. Let me stop share the note and go to the calculator. We need to figure out what's 10 to the power negative 12.65. 10 raised to the power negative, very important. On the TID4 calculator, the negative is not a minus sign. Do not use this button. Use the negative on the right bottom right corner in the parentheses. That's negative. Negative 12.65. Let me just double check the entry. Negative 12.6. Yeah, that's correct. Equals. The calculator give you this scientific form, scientific notation, right? That's what the question requires you. What does this mean? Let me copy paste and explain what does this mean. And we can go back the note and write something there. Right here. Okay, so let me stop share the calculator. Let's go back the study guide. Here. And for some reason, go on the next page. Go on the next page. What does this mean? This means the result is a 0 point. We're going to have 12 zeros. 2, 2, 3, 8, 7, 2, 11, 4. Around equal to, actually. And the system doesn't want you to enter something like that. So it says, keep this scientific notation. The e to the power negative 13 is actually means 10 to the power negative 13, okay? And then we want to round the decimal 2.23, 872, 11, 4 to at least 2 decimal places. Then let's keep 2 decimal places. Let's do 2.24. Because the 8 here is bigger than 5, we round it up, right? So 2.24. 2.24 times 10 to the power negative 13. So manually handwritten of the result in a scientific notation is this. Let's see. The question says, enter scientific notation as follows. Would it be entered as, okay? So I guess the question wants you to enter 2.24. You enter 2.24. E negative 13. I think that's what the question wants you to enter. Yeah. Enter scientific notation as follows. Would it be entered as? Yeah, what does that mean? Explicit scientific notation with at least 2 decimal places. Write the answer in enter scientific notation as follows. Okay, I think they want you to enter this. So you should do 2.24 times, like 10 to the power of negative 13. All right, you're gonna do that. I will look at your entry for this specific question 9 after exam. If the format compromise your grade, I will override that. So no worry about it. I think it means to enter this or to be entered as. They want you to do this. Okay, so that's question number 9. Question number 10. An investment of $27,700 earns 9.6% annual interest, compounded continuously. If no funds are added or removed from this account, what is the future value of the investment after 21 years? Round your answer to the nearest penny. We need to know the formula for compound interest when the interest is compounded continuously. The formula is A equals PERT. RT is the exponent of E. A, accumulated balance. Accumulated balance is the future value. P is the principal. Okay, is the present value. Yeah, PV means present value. You don't have to know that, just another way to express it. And R is the annual interest rate. Is given is 9.6% in this case. T is time in years. All right, we understand the meanings of those variables in the formula. Now we can plug in what we have. Then an investment of $27,700. That is the principal. Okay, P is given. That's the principal. So principal 27,700. Put it here. E to the power of R. R is given 9.6%. Percent is not very convenient when we actually calculate. So we are going to convert 9.6% as equivalent decimal. As its equivalent decimal, 9.6% is 0.096. So 0.096 here is R times T. T is also given. T says 21 years later. So T equals 21. So times 21 here. All right. Then we are able to find the future value of A, accumulated the balance in an account after 21 years. Okay, I'm gonna show you how to use the TID4 calculator to get it done. If you do not have a TID4 calculator, what do? Of course, I hope you do, right? And you do this part first. Actually, you do the exponent first, and raise that, and apply the exponential function with E, and then multiply by 27,700. But if you have a TID4 calculator, I'm gonna show you. It's gonna be very convenient. Stop share, and go to the calculator. Good thing about the TID4 calculator is you can just enter the expression. I remember it's 27,700. I'll double check later. Multiply by second ln, which gave you an exponential function with base E. In the exponent, we're gonna have a multiplication, all right? R is 9.6%, so 0.096 times 21 times 21. Maybe your calculator requires a parenthesis to frame the exponent. Mine doesn't, because obviously it is in the exponent, right? But if yours doesn't show the same thing, you have to figure it out, play with your calculator, get familiar with it. You have to put a parenthesis here. Let me double check the entry. 27700.096 times 21. Okay, that's correct. And then enter, right? So in the future, after 21 years, you will end up with this much money. You will end up with this much money. Let's see how we run the result. Let's go back. The study guide. Study guide. It's right here. The answer equal to, I don't know if it let me to copy here. It go down to the next page as well. Round your answer to the nearest penny or nearest cent, right? So our answer is going to be, we're going to round it down because 2 is less than 5. Round it down. Okay, your answer is supposed to be this. $207,978, 2 cents. So this is the answer. All right, guys. Yeah, I'm recording the class. Later you can see the video. This question isn't that challenging if you know the formula. Question number 11. If $14,500 is invested at an interest rate of 8% per year, find the value of the investment at the end of 7 years for the following compounding methods. Give your answers to the nearest penny. Okay, so it's all about the formulas. So you just need to memorize those formulas, okay? You just need to memorize those formulas. It does mention continuous. Continuous have different formula. We use the formula in the previous problem. Knowing continuous, the formula is A equals P times e to the power RT. The meaning of the variables I have already explained. That's part D, right? Part A, the interest compounded annually. So part A to part C, the formula is going to be, I'm going to put them together. Part A, part B, part C, the formula is going to be A equals P times 1 plus R over N to the power RT. And knowing if you want to know something extra, the yellow part in the parentheses, that is called a compounding factor. All right. So A again is a accumulated balance in the future. P is the principal you invested in. R is the annual interest rate. R has to be annual interest rate, okay? Time is T. T is time in year. What about N? Oh my gosh, this is not RT, it's NT. Sorry, NT. N here is the number of times the interest is compounded per year in 1 year, okay? N equals 1 if it's annually. N equals 2 if it's semi-annually, twice a year, right? So semi-annually. N equals 12 if it's monthly. Okay, yeah, that's all we need to do. It also could be quarterly or daily, but we don't have that in this question. All right, so now we have the formula ready. Let's do the calculation. I don't really think it's challenging. Once you have the formula, you just plugging in, right? Part A, use the formula A equals P, but N gonna be 1, so 1 plus R to the power of T, no N. N is 1, so divided by 1 or multiplied by 1 is just nothing, right? P is given, the principal is 14,500. 14,500. 1 plus annual interest rate, I remember is 8%. 8% is 0.08 to the power of T. T says how many years? 7 years, so T equals 7. All right, you just need to enter this in the calculator and calculate it. I think you can do it yourself, right? Part B, semi-annually. A equals P 1 plus R over 2 to the power of 2T. Okay, that's the formula for semi-annual case. N is 2. And we plug in the value for the principal, 14,500. 1 plus annual interest rate is 0.08. Divide by 2 actually give you the semi-annual interest rate. And to the power of 2T. 7 years, twice a year, so 14 times. I believe you can do this as well. Part C, A equals P. Since the part C is to compound the monthly, N equals 12. So 1 plus R over 12 to the power of 12T. Principal 14,500. In the parentheses, we have 1 plus the monthly interest rate. Divided the annual interest rate by 12, we got a monthly interest rate. Yeah, divide the annual interest rate by 12, we get a monthly interest rate. And then to the power of how many times in total the interest compounded, right? for 7 years, 12 times a year, 7 is going to be 84, right? So 12 times 7 is going to be 84. So in total, 84 times. 84 times. And I believe you can do the calculation in the calculator by yourself. Part D, continuously. A equals P E R T. One interesting about the exam is I went over the homework assignments in Unit 4. I wasn't impressed by the proportion of compound interest problem in the homework, but it has a bigger proportion in the test, which might be a good thing because I think my foundation tool cover those. Yeah, it's a foundation tool thing. Okay, so just the plugging in initial investment or the principal 14,500 times e to the power 0.08 times 7. R is 8%, in decimal 0.08 for 7 years, so times 7. The result is I want to show you. I would recommend you finish the calculation. I don't just want to spend the time here, just in case we fall short of the time later. You will see with the same principle and same time, when the time of the interest is compounded increases, your future values is increased, is getting bigger. So we prefer more often the interest compounded, right? You will see the result later once you have the calculation. Now let's move to number 12. We have 20 questions. We only have 43 minutes left. So yes, pretty tough time. Number 12, the function below has the form f of x equals b to the power of x plus k. This makes it a lot easier because the structure of the function is given. Basically, is the mother function of the exponential function is shifted vertically or shifted up by k unit. Depends on the positive or negative of k, right? If k is positive, go up. If k is negative, go down. So only vertically shift. As you can see, the given graph has asymptote at y equals -1, 1 unit below of the origin, right? So we know the mother function has a horizontal asymptote y equals 0. Yeah, this is supposed to be the asymptote for this function, mother function. But now this function has asymptote y equals -1. That means the mother function bring down 1 unit to that means our function f of x can be acquired by moving the mother function graph downward 1 unit. So now we know k is -1. I hope the explanation is understandable. Right? Originally, the asymptote is y equals 0, but now it's y equals -1. That means the graph is shifted downward 1 unit. That means the k is -1. K has to be -1. Also, because the graph is decay, b has to be less than 1. Of course, it has to be positive. So with those two information from the graph, let's choose the correct function. It makes it easier when it's a multiple choice question, right? The first one seems right because the base half is between 0 and 1 and -1. The second one is out. This one is not. This one is not. This one's not +1, right? This one's +1. And this one is -1, but the base is bigger than 1, supposed to be increasing, but our graph is decreasing. So no, it's wrong. This one +1 is wrong. This one -2 is wrong, right? And this one is -2 is also wrong. So the first one is the correct answer. The first answer choice is the correct answer. I think this is doable. I know there are challenging problems in Lumen about the graphing, but this graphing problem is totally doable. Next, question number 13. Draw the graph of 3 to the power of x minus 5. This is also doable. I do not have the tool. Since this problem is on the review, you would need to know how to do it, right? And the question instructs you very in detail. It says, the first point will mark the horizontal asymptote. Then you will give 2 more points on the graph to accomplish the graph here, all right? So firstly, we need to find the asymptote. We know this mother function 3 to the power of x, has a horizontal asymptote y equals 0, the horizontal scale, right? But now our f of x is 3 to the power of x minus 5. So you're going to go down 5 units. So the horizontal asymptote is going to be y equals -5. So the y equals -5 is here. That's the horizontal asymptote. All right. And then also the base of the exponential function is bigger than 1. So it's increasing. Okay. It's going to be an exponential growth. It says you will give 2 points on the graph of the function f of x, right? So 1 point, knowing 1 point is going to be here. Okay. Why? Because remember 3 to the power of x passes through 0, 1. Yeah, the original mother function always passes. So that's the y-intercept of the exponential function. I mentioned that at the very beginning of this chapter. We need to know the graph of the mother function for exponential and log function. So originally, or what I'm trying to say is 3 to the power of x has y-intercept 0, 1, so it passes here. But now the function f is go down 5 units, right? So you go down 1, 2, 3, 4, 5. So the new function f of x gonna passing through 0, 94, 0, 94. Okay, 0, 94. And that is 1 unit above the asymptote. So that is 1 point. You need 1 more point. How do you find the 1 more point? Look at this function. The function is y equals 3 to the power of x minus 5. We just need 1 more point. How about you can give any point, right? Yeah, the y-intercept we got already. And another point we can do when x equals 2. When x equals 2, 3 to the power of 2 is 9. 9 minus 5 is 4. And that would be a good one, right? Yeah, plugging in x equals 2. 3 to the power of second power. 3 squared is 9. 9 minus 5 is 4. So 2, 4. 2, 4, where is it? 2 is here, 4 here. Right? And you don't have to draw it. The system would help you to draw it. All you need to do is to have the horizontal asymptote, and then point here, and then point here, and then we'll give you the graph. The graph would be look like this. Okay. Give it a try in your Lumen system. You have done your homework, so you should know how, right? It's also totally doable. Number 14. The graph below shows a transformation of the exponential growth function y equals 2 to the power of x, basis 2. Write an equation of the form. Yeah, this makes it a lot easier. They give you the structure of the daughter function for the graph above. Very good. That's totally doable. So the new function is going to be y equals a times 2 to the power of x plus k. What happened is, so this is increasing, right? Since the function we have here is decreasing. I think it has been flipped. It has been flipped to 0,3 to 0,3. It has been reflected with respect to the x-axis, right? And then go down 1 unit. Go down 1, 2, 3, 4, 4 units. It's supposed to be here. Let's give it a try. And also we could not using transformation, just use algebra. How do we use algebra? We find some points. This is a very obvious point, right? 0,3. And this is a 2, look at it closer. Yeah, 2, 0. 2, 0. And I think that's it. But you know, 2 pairs would be enough. Why? Because we only have 2 unknown. We have 2 unknown, which is needed 2 equations. Let's plug in the first pair of point. When x equals 0, y equals 3. Y equals 3. When x equals 0, right? When x equals 0, there's a 0 on the shoulder of 2 and plus k. And simplify, we have 3 equals 2 to the power of 0 is 1, right? A plus k. Okay, let me highlight that equation 1. And now let's plug in the second pair, 2, 0. When x equals 2, y equals 0. So y equals 0. 2, when x equals 2. So we have second power on the shoulder of the base, 2, and plus k. And then simplify. 2 to the power of 2 squared is 4, so 4a plus k. Now we have the second equation, right? In previous chapters, we have learned a system of equations. This is a simple system of equations. And let me put them together, and we can solve the system. Yeah, instead of using transformation, we also can use just solve the equation for the 2 unknowns, right? 4a plus k. I'm going to label this equation as 1, this equation as 2. I'm going to multiply equation 1 by -1 and add it to equation 2. We can also get it done. We can also get it done by using equation 2 to minus equation 1. Let's see if you can see it, okay? If we use equation 2 to minus equation 1, be careful with the sign. Left side of 2 is 0. 0 minus 3 equals 4a minus a, right? Yeah. This k cancelled because I use 2 to minus 1. The k disappear. And 4a minus a, you know, actually, if we give me one moment. If I switch the order of the 2 equations, it will look better. We have the 2 equations in pink, right? And this time I'm going to write the second equation on the top. Write the first equation on the bottom. Okay, this will look better. And this is 1, this is 2. And if we use 1 to minus 2, okay, use 1 to minus 2. On the left side, 0 minus 3, -3. 4a minus a, 3a feel more comfortable, right? K minus k is 0. And now we have 3a equals -3 divided by 3. A equals -1. Once we have a equals -1, we can plug in back to number 2, right? Number 2, 3 equals a is -1 plus k. And k has to be 4 in order to get a 3 on the left side. -1 plus 4 is 3. So the function write an equation of the form. Write an equation of the form for the graph above. And you do not need to enter y equal because it's already have y equals. And we're going to write -2 to the power of x plus, what is k again? K is 4. K is 4. K is 4. All right, so it flipped. It's actually it's actually, if we want to look at the transformation, factor -1 out is go down 4 units first and then flip over. And that's actually the transformation. The unit sign, it is somewhere, is easy to make mistake. So this is not bad method. We can use this method. All right. This is question number 14. Let's keep going. Question number 15. Evaluate the expression reduced to simplest form. Okay. This one just equals 2. Why? Because this part, log2 is 1. We have the formula explained, right? When we have a log whose base and argument are identical, the log equals 1. So 2 to the power first, 2 to the power 1 equals 2. Part B. We actually mentioned that formula as well. If you remember, B, log with bx is x. But if you do not remember, what we can do is part B is 10 to the power log 6 equals x. We want to know what is x, right? So this is exponential form. This is the log, right? That's the log on the shoulder. The log equals base. The log equals, this is exponential form. If we switch the logarithmic form, we have base 10. Anti, this is going to be that's going to be argument. So as you can see, x equals to be 6, right? X is going to be 6. If you know this formula, you can know it's 6 directly, because this base 10 cancel the log with base 10. Because exponential function with base 10 and the logarithmic function with base 10, they are inverse of each other. Yeah, they are inverse of each other, so they cancel each other. So you have 6. If you could see that, same with here. The e would cancel the ln, so we have 8. Next, question 16. Evaluate using a calculator and rounded to 4 decimal places. 4 decimal places. This is about using change of base formula, okay? What we're going to do is to write the expression, the log expression with base 0.69 and with argument 0.24 as ln 0.24 over ln 0.69. So the base of the original log becomes the anti of the bottom. Become the argument of the bottom. And the argument of the original log becomes the argument of the numerator. So just like that. ln 0.24 over ln 0.69. I need to share the calculator. ln. What's the value again? 424 divided by ln 469. Okay, keep 4 decimal places. 3.8460, because 1 is less than 5, go to down, round it down. 3.8460. All right, and that's it. Question number 17. Identifying the characteristic of a log function. Complete the table below for the log function f of x equals.
We're still looking at your calculator.
Oh, sorry. Yeah, I'm still getting used to the Zoom, because for years I have been using Ultra. Ultra has the option to share the whole desk. I don't have to switch back and forth. You have the note now, yeah. Number 17. identifying the characteristics of a log function, completing the table for this function f of x equals log with base 3, and argument is x plus 2. So we add 2 to the variable x. Now that means we shift to the left 2 units, okay? Shift log with base 3 of x, the mother function, to the left 3 units to get this function. All right, so firstly, 2 units, no, sorry, 2 units. 2 units. The mother function, log with base 3 of x, since the base 3 is bigger than 1, log growth, logarithmic growth, increasing. Move the graph of this function to the left 2 units, we would have the function that in this problem, okay? Domain, use the interval notation, okay? So we want to know the graph of a log, the mother function, right? The mother function, if you remember, look like that. Log with base 3 of x. Shift to the left 2 units, 1, 2. So this is the vertical asymptote. So the graph is going to look like something like this. Okay, that's log with base 3x plus 2. The shift to the left does change the domain. Okay? But we don't have to use the graphing method to find the domain. We use the algebraic method to find the domain. For a log function, I mentioned this before. For a log function, the argument has to be positive. Cannot be 0, cannot be negative, has to be positive. The argument of this function is x plus 2. So we have to make x plus 2 bigger than 0. X plus 2 has to be bigger than 0. And minus 2 from each side of the inequality, we have x is bigger than -2. And that's the domain, okay? Is from -2 to past infinity. If we use the algebraic method, the argument has to be positive. We make the argument x plus 2 bigger than 0 and solve the inequality, we get x is bigger than -2. And if we use the graphing method, it's still okay because the mother function has a domain 0 to infinity, right? And now you move to the left 2 units, of course the domain become -2 to the infinity because you moved to the left 2 units, right? Yeah, same thing. Either algebraic method or the graphical method, you should have the same thing. Range does not change. The range of the mother function is all real. From -infinity to past infinity, you shift it to the left 2 units, it does not change the range. It is still all real. It is still all real. -infinity to past infinity. I know those are tons of information, but this is a 16-week class. Also, you have to get those information in order to feel more comfortable when you take the calculus. X-intercept, okay? X-intercept. The mother function has x-intercept 1, 0, right? Then the daughter function, the red one, is gonna have x-intercept 1 minus 2, -1, 0. As you can see, this big point, right? Because you moved to the left twice. So 1 minus 2 is -1. The x-intercept is -1, 0. Vertical asymptote. Since the mother function has a vertical asymptote x equals 0, so the daughter function, after we move to the left 2 units, the vertical asymptote becomes x equals -2, right? Yeah, it's right here. This is the asymptote. So x equals -2. And then I still think the graphing method would help a lot. I did emphasize many times the very beginning of this chapter, is so important to know the four graphs: exponential growth, exponential decay, logarithmic growth, logarithmic decay, because all the characteristics of an exponential log function is in the graph. Like if you know the black curve that represents this mother function, log with base 3 of x, is a log growth function, and you know it's gonna move to the left. This is also a tricky part. Is where the common mistake occurs. To the left 2 units, okay, it's not to the right 2 units. That's something we learn from transformation. You move to the left 2 units, and then your x-intercept move to the left 2 units, and your vertical asymptote move to the left 2 units. Your domain move to the left 2 units, right? But range doesn't change. So if you understand the graph very well, which is important, this is not too bad. This is a good problem. Number 18. Solve exactly the given equation for x. This is to solve an exponential equation. The base to the left side is 10. The base to the right side is 7. Not convenient. Not convenient to write both sides as the power of the same base, right? So we're going to use the second method. The second method is take ln. Take ln. And the exponent by the power rule can be moving in front of it. It's too messy. Okay, let me do it again. So we're going to have ln 10 to the power of 5x minus 4 equals ln 7 to the power of 6x minus 8. By the power rule, we have used power rule many times. The exponent in the argument can be brought in front of the log. Same with this one. Okay, don't forget to put 8 parentheses. Then we have, this one you can do log actually, common log. Then you have a 1 on the left side, but it really doesn't make too much difference. Does not make too much difference. So if we have 5x minus 4 in the front, in the parentheses, and we multiply ln 10 equals here 6x minus 8 in the parentheses, multiply ln 7. Okay? And then we're going to distribute, remove the parentheses. We have 5x times ln 10, which ln 10, and then times x, and minus 4 ln 10. I hope you see it. It's a distributive property. 5x times ln 10 is 5 times ln 10 and times x. 94 times ln 10 is 94 ln 10. On the right side, 6x times ln 7 is 6 ln 7 times x, and minus 8 ln 7. All right? So as you can see, we have 4 terms in the equation. 2 of them with x, the other 2 of them do not have x. Okay, so I'm going to collect like terms now. I'm going to add 4 ln 10 to each side. Then those cancel, right? Those cancel. And the left side, now I have 5 ln 10 x. On the right side, we would have 6 ln 7 x minus 8 ln 7 plus 4 ln 10. And the next step, I'm going to minus 6 ln 7 x minus 6 ln 7 x, and they cancel. And on the right side, we're going to have negative 8 ln 7 plus 4 ln 10. On the left, we're going to have 5 ln 10 x minus 6 ln 7 x. We collected like terms. We collect like terms for the purpose of combining them. Left side, we can combine the 2 like terms. So if you have 9x minus 5x, you know how to combine, right? It's just now the coefficients looks more complicated. You can also see this as factor x out. If we factor x out, then the coefficient part would become 5 ln 10 minus 6 ln 7 equals on the right side negative 8 ln I'm going to switch the order. I'm going to do ln 10 first. 4 ln 10 minus 8 ln 7. Okay, and then we're going to divide each side by 5 ln 10 minus 6 ln 7. 5 ln 10 minus 6 ln 7. Cancel. So we have x equals 4 ln 10 minus 8 ln 7 all over 5 ln 10 minus 6 ln 7. What did it say? The question says solve exactly. So you do not need to enter in a calculator. It's going to be an irrational number. You would have a round if you enter the answer as decimal. But the question does not want you to enter a decimal. They want you to enter the exact answer. And that's going to be like that. All right. So if the very beginning, what we have done is, what we do is to use a common log instead, log with base 10, log with base 10. And we might save a little bit of energy because log with base 10 out of 10 is going to be 1. But with ln, it's not that bad either. So your answer is not unique. Your answer is not unique, okay? Let's see if we have time later to come back. If we have time to come back, we can do it again. And that's number 18. Number 19, solve x. This is a log equation. A very, very important thing about log equation is we have to double check the result as a necessary step because we might have extraneous solutions. So that's a must. Let's see how do we solve this log equation. We have 2 logs on the left side. We have a 1 on the right side. Number 1 on the right side. So log, so allow me to write a capital log, capital L, then they remind me is base 10. Log base 10 x plus 3 plus log base 10 common log of minus common log of x plus 2 equals number 1. We're going to condense the left side. We're going to condense the left side by using the quotient rule. So keep the base, which is 10, and then take the quotient of the 2 arguments, x plus 3 over x plus 2. Okay, this x plus 3 goes on the top. This x minus x plus 2 goes on the bottom. Equals 1. All right, and then we are going to identify the base, argument, log from this equation because the equation is in a log form. Base is a 10. Argument x plus 3 all over x plus 2. Log is 1. So to convert, we use base 10 raised to the power 1 equals the argument x plus 3 over x plus 2. 10 to the power 1 is 10. So allow me to switch the sides, okay? I'd like to feel more comfortable with x plus 3 over x plus 2 on the left side equals 10. And this becomes a what? This becomes a rational equation, actually. And we can multiply each side by x plus 2. That's fine. X plus 2. And then those two cancel, right? Then we have x plus 3 on the left side equals 10 times x plus 2 on the right side. So x plus 3 equals distribute 10x plus 20. And we have x plus 3. So we can minus x. Minus x, we have 3 equals 10x minus 1x, 9x plus 20. Minus 20, minus 20. We have negative 17 equals 9x. Divided by 9, divided by 9. We have x equals negative 17 over 9. That's our proposed solution. Proposed solution. We have to double check. We have to check. Bring it back. Negative 17 over 9. Negative 17 over 9. X equals negative 17 over 9. Would that number make this argument as negative? No. X plus 3. When x is a negative 17 over 9, so plug in negative 17 over 9 plus 3. And 3 is 27 over 9. So we're going to have a 10 over 9, which is positive. That's fine. And with the value of x make x plus 2. The second argument is 0 as negative. Let's see, x plus 2, negative 17 over 9. I feel like we did this problem in a guided note. Plus 2. So negative 17 over 9 plus 2 is 18 over 9. So we end up with 1 over 9 is also positive. So you have log 10 over 9. That's log 1 over 9. It's log 10, which is 1. Okay, we keep this solution. The exact solution is negative 17 over 9. It is a solution. Okay, that's number 19. The last problem, number 20. Given the graph of the log function, g of x equals log base 4 of x, increasing. Okay, because base is bigger than 1. The graph of the function f of x equals log 4x plus 9 can be obtained from the graph of g of x by shifting the graph of g obviously go up, right? Upward, I believe the drop-down menu would give you an option to select go up, right? This, we can get the graph of f by shifting from the graph of g, by shifting the graph of g upward 9 units, because plus 9, right? Identify the domain of the range for the function f. Okay, when the two functions appear, you have to make sure which function you are considering. We're considering f of x. F of x is log with base 4 of x plus 9. Okay, domain is the same. Domain is all positive because the domain requires the argument positive. So argument positive x bigger than 0, 0 to infinity. Range, you go up 9. Range originally is all real. You go up 9 units, doesn't change the range. The range is still all real. The range is still all real. All right. Yeah, it's just vertically shift upward 9 units. It doesn't change the domain. It does not change the range either. The range originally is negative infinity to plus infinity. You add 9 to infinity, still infinity. That's the last problem. I said if we have time, we can, do this one more time. I'll do that here. Insert a break. Okay. So if we do log with base 10, would that make it a little bit easier? It might, right? So you can try both. We're going to do log, which is base 10. 10 to the power of 5x minus 4 equals On the right side, log with base 10, 7 to the power of 6x minus 8. Same thing by the power rule, we can move the exponent in the argument in front of the log. Then we have 5x minus 4 log of 10 equals 6x minus 8 log of 7. Log of 10 is 1. Okay, that might make it a little bit simpler. So we have 5x minus 4 on the left side. We only need to consider to distribute on the right side now. And we have 6 log 7 times x minus 8 log 7, right? And then we're going to collect like terms. A lot of times I use plus, same thing to both sides, and minus, same thing from both sides. Actually, the method I teach in the class, in the foundation class, is to change the sign and the side and side. So what I'm trying to say is, if we want to move this term over, do it. But just remember, you have to change the sign of it. So 6 log 7x. Same with here. We want to move this term over, do it, but change the sign. It's negative 4 on the left side, now it's positive 4 on the right side. Minus 8 log 7, right? And factor x out, 5 minus 6 log 7x equals 4 minus 8 log 7. And then divide each side by the coefficient of x, which is 5 minus 6 log 7. 5 minus 6 log 7. Cancel, we have x isolated, and the answer is this. Actually, it's a little bit better, right? Yeah, a little bit simpler, because we have a 10 here. And actually, we should take advantage of it. Use log better than ln. But ln is not too bad either. Okay. So that's everything for today. You have the time all the way by May 10th. You have any, what day today? Today is 29. How many days we have? Oh, 2 weeks. No, we don't have 2 weeks. 1, 2, 3, 4. 10 days. You have 10 days to prepare for your exams, both Unit 4 test and your final, if you want to take a final. Remember, the final could replace one of your exams of Unit 3 and Unit 4. So, and you won't lose nothing by taking the final. More important is the Unit 4 test. Let's see, let me stop, it doesn't, okay, let me stop the recording. Stop recording and then do the attendance. Interesting. It says stop the recording. Stop recording. It's still actually okay. Still doing it. Let's see who attended the class. 5 of you. Kaida, Michael, Max, Liza, and Ether. Okay. I will mark your attendance later. Do you have any questions?
Yes, Professor.
Yes, please.
It's 10 days will be on May 13th, right?
Say again, sorry.
The 10th day will be May 13th. I just want to make sure.
Yeah, the last day of the semester. No more, no extension after that. That's the last day of the semester. The campus is gonna close after that. Yeah. I also reopened. Yeah, I also reopened your assignments in Unit 4. Sounds good? You can email me if you have any questions. All right, guys?
Sounds good.
Okay, what about Thursday? Since we are you sure you want to stop recording to the since we finished all the lecture, so what do we do on Thursday? We're gonna do Q&A, questions and answers. We're gonna do tutoring. Attending the class on Thursday is optional. If you have questions, you're welcome to drop by the meeting and ask the question. If you feel good and you have something else to do, and you can just make that arrangement. All right, guys. I hope to see you
Okay,
on
thank
Tuesday.
you.
And you have a good the rest of the semester.
Thank you.
Bye-bye.
The
Okay, thank
surveys
you.
that we did
Bye.
for extra credit, when is the 2% extra credit gonna go in there into our
The
grade?
2% will not be seen in Lumen. It will be seen in your in my grade book of the class.
Okay,
So yeah,
so it's
suppose
already in there?
no, I don't have that. So I need to submit your grade, right? When I submit your grade to the college, I added 2%, actually 4%.
Oh, okay.
Did you do the survey? You do the survey, you have 2%. But you
Yeah.
also should have done the introduce yourself and agree on the statement, right? So that's also 2%. So actually we have a 4%.
Okay.
Yeah. Sounds good?
Yep.
All right. Have a good one, everyone. Bye-bye.
Bye. Have a good one.
You too. Bye-bye.